Okay, today we're going to talk about measures of central tendency. In particular, you've already seen these before in 7th grade, so mean, median, and mode. We're going to have a particular focus today, however, which is not a 7th grade standard, so this is new to this year. Integrated Algebra S4, compare and contrast the appropriateness of different measures of central tendency. So we are going to have a set of data. We're going to look at it. We're going to get the 3 measures of central tendency, and then we're going to talk about which ones may or may not be appropriate. Okay, so the first thing is let's recall what we mean by mean. Now, sometimes mean is called arithmetic mean or numerical average, just because the word average can be used to. It doesn't always mean numerical average. It doesn't always mean numerical average. So we have to be more specific when we say the word average to say either numerical average or arithmetic mean. So it doesn't always mean these two things. Now, a lot of times mean is represented with X bar, and you've seen that before. That's read as X bar. That's the symbol that we use to represent mean. So let's say your recent test scores are 92, 80, 86, 72, and 84, and you would like to calculate your mean test score. So X bar is equal to, and what you do is you sum all of your data points up, and then you divide by the number of data points you have. So there's 1, 2, 3, 4, 5 that you had, and you had 85. So your average test score is an 85%. I'm assuming that it's a percent, I guess, but they didn't really tell us it was a percent, but I'm assuming that it's out of 100. Okay, the median. The median is, to find the median, you have to first arrange the numbers in numerical order. All right, there's 2 different ways to do it if you have an odd or an even number in your set. So let's go over this in this below. If you have an odd number in your data set, then the median is just the number that's right in the center. So for instance, if you have 1, 2, 3, 4, 5, 6, 7 numbers, what you do to find that, you'll know the number that the order that the median is in. So you go 7 divided by 2, so that's 3.5. So you say that the 4th number is your median. Okay, and it's important for you to have this down. You know how to do the cross out method of crossing the numbers out as you go to find the middle number, but that's not really an efficient technique if you have a large data set. So if I give you 39 numbers in your data set, you need to know that the middle number is at, 39 divided by 2 is 38 divided by 2, which is 19.5. Okay, so your middle number would be the 20th number. Okay, you don't want to go ahead, you don't want to use the cross-out technique if you have 39 numbers because it's just too large. So you divide it by 2 and round up, and that will be, if you have an odd number of numbers in your data set, that will be your median number. Now, if you have a even number in your data set, it gets a little trickier, but it's not that hard. So let's say that you have you added, they give you this is a scenario about a car wash and median ages at the car wash. So they added another age, which was 19. So the median age, or they added the age of 21 rather. So the median age in an even number in a data set is going to be the average of the 2 middle numbers. Okay, now this data set has 1, 2, 3, 4, 5, 6, 7, 8. So the middle numbers are going to be the 4th and 5th numbers. Okay, that's because there's 3 numbers below it. Okay, right? There's the 1st, the 2nd, and the 3rd, and there's 3 numbers above it. There's the 6th, the 7th, the 8th numbers. So the 4th and 5th number is going to be the average. So again, if I give you a data set that's really large, like if it's 42 numbers, in order to find the middle 2 numbers, take that number, divide it by 2. Okay, that would get 21. So it would be the 21st and the 22nd number. Okay. So it's really important for you to write this information down because that's new information. And we're going to be dealing with data sets that are fairly large, and to use the cross-out technique is just, I don't want to see you using that anymore because that's not a very efficient technique. Okay, so the mode is the most frequently occurring number. Now, we don't often use mode when we have numerical data, when we have quantitative data. We do often use it for categorical data, and I'm going to go over that in just a second. But let's look at a mode for quantitative data. So to find the mode for a set of data, find the number of numbers that occur most often. Okay, so there's a few different situations. If one number occurs most often, then that number is the mode. If two or more numbers appear more often than the other data set, and they have the same frequency, so they all appear like 10 times or 11 times or so on, or they all appear twice, then each of those numbers is the mode. Okay, and then if no number in the data set occurs with more frequency than others, then there's no mode. So let's go over, there's 5 situations here that we can go over to explain this. So the ages of employees at the car wash, that was 17, 17, 18, 19, 20, and 46. So clearly 17 is the mode because it occurs 3 times, where the other points only occur once. The number of hours each of 6 students spent reading a book are 6, 6, 8, 11, 14, 21. The most frequently occurring number is 6. But they go on to say that this is not a useful measure of central tendency, because 6, even though it's the mode, it only occurred twice, where every other number occurred just once more. But if you look at the data set, it's not a very good measure of where the center of the data is. We wouldn't say with this data set that most students read around 6 books, or a number of hours. We wouldn't say that most students spent around 6 hours reading a book, because most of the hours are above the mode. So there's 8, 11, 14, and even 21 hours above the mode. So 6 is not a useful measure of central tendency. Okay, so when you find the mode, it's not just a clear-cut answer as to whether or not that's helpful. You have to look at your data set and do some analyzing on your data set to see if that is a measure of central tendency or a good reflection of where the center of your data is. Okay. The number of photographs printed on each of Renee's last 6 rolls were 8, 8, 9, 11, 11, and 12. So 8 and 11 appear both twice. So we say that there's 2 modes. We don't take an average of these 2 numbers, since the mode tells us where most of the scores appear. So that's really important. It's not like a median where we take an average. We also call this data set bimodal, which means that there's 2 modes. Okay? So this bimodal may be a new piece of information, so make sure to write that in your notes. The number of people living in each of Merrill Streets are 2, 2, 3, 3, 4, 5, 5, 6, and 8. There are 3 modes. So 2, 3, and 5 occur both twice in your data set. So those are your 3 modes. Finally, Ralph's test scores on science are 72, 80, 86, 93, and 94. Here, no number appears more than any other number. So there's no mode. Okay? So this is no mode. This next thing has 3 modes. This was bimodal, so there were 2 modes. Okay? And this was 1 mode. And this was also 1 mode. Okay. Now, this is a chart. Make sure to have this in your notes. This is really important because this is a new piece of information from that you're getting in 8th grade. This goes over the best measure of central tendency given the type of data that you have. So first of all, and you may also, this is the chart that you should have in your notes, but you may also want to write down what I'm saying, because it may not be, everything that's in this chart may not help you understand what this chart means. So let's say if the type of data is categorical. So let's say you asked everyone their favorite colors, and you got green and blue, and then another person said green, and someone said black, and someone said yellow, and someone said white. Okay, well, there's no way that you would get the median or the mean. All right, there's no way you could get it because it's not numerical information. So for us, when the data is categorical, the mode is absolutely the best way to get a measure of central tendency. Or in this case, it's a measure of what most people said. Okay, so the mode is always used in cases where you have qualitative data, because you can't use median or mean. Okay, so if you have quantitative data where the average number has no real meaning, so let's say you asked people to rank. Let's say that in the last 3 presidents, Clinton, Clinton, Bush, and Obama. Let's say you asked people to rank their favorite president, and some people said in this order 1, 2, and 3. Some people said that Obama is the second, Bush is the first, and Clinton is the first and Bush is the third. Some people, maybe if they're Republican, they say Bush is the first, maybe Clinton is the second, Obama is the third. So what they're doing is they're ranking these numbers. So here, it's not, so if you're trying to figure out how many people chose Obama as their first rank, you do not want to add these numbers and get an average of them, because that doesn't make any sense. Okay, so for you want to find the median of these numbers as opposed to the mean, because the mean, these numbers 1, 2, and 3, they don't really hold the same information as numerical data does. Yes, they are numbers, but they do not have they're only a way to order your data. So if the numbers are used as a way to order your data, it's called ordinal. So they're ordinal numbers. Okay, that's different from collecting information like height or weight or sunlight or plant growth in centimeters. These numbers are not used in the same way. They're just a way to show the order of a categorical piece of information. So in this case, your median is the best way to find that out. Okay, or it's the best measure of central tendency. Now, for the most part, you're going to see these last two. All right, you may not see you'll see categorical data sometimes, but ordinal data you may not see until you're taking a statistics class in high school. But if you have quantitative data that has an outlier, this is super important. So if you have data that has a number that's out either way far off on the lower range or way far off in the upper range, then you do not want to use a mean, because your average is going to be pulled one way or another. I'm going to give you an example of that in just a minute. Okay, so if you have an outlier, you don't want to use a mean. You want to use a median as a better measure of central tendency. But if you have data that's acting nicely, it doesn't have an outlier, then the mean is the best measure of central tendency. Okay, so let's give an example. So we have an example of hourly wages of an employee of employees at a local restaurant. Okay, and this is called a dot plot. Even though there's X's there, it's still called a dot plot. It looks like the wages per hour are going in a numerical order, so it looks like a number line, and the X's are the number of employees receiving that wage per hour. Now, let's look at your data. So typically a measure of central tendency measures where the most, so if you were going to ask, what does the most amount of employees get for a wage at this restaurant? Well, we can sort of look at our data and we can say, well, it looks like there's a lot of X's on the $6.25. Okay, so we'd probably want to measure a central tendency that was reflective of how many employees received this wage, and certainly between these two wages, this accounts for, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 employees, right? But 1, 2, 3, 4, 5, 6, 7, 8 employees receive between either $6.25 or $6.50 an hour. So certainly we're looking for a measure of central tendency that reflects our intuition that if I'm asking what the average amount of salary that employees receive at a restaurant, that it's going to be mostly between these two. So the mean, we get the mean. Now they performed a shortcut in their calculation, which is really important to note. To get the so there's 5 employees that receive $6.25. So instead of adding $6.25 5 times, they took $6.25 and multiplied it by 5. And then they took $6.50 and multiplied it by 3 because 3 employees received $6.50. Then $7, they could multiply that by 1 or just leave it as $7. And $8.25 gets you that X right there. And they divided it by 10, okay? And they got $6.60. All right. Now, do most employees receive $6.60? No, because most employees, we said, 8 out of 10 employees received $6.50 or below. So even though $6.60 is not that far off, it's still not a measure that really reflects what the average wage or wage of the employees at the restaurant is. We get the median. The median is the center of two numbers in the list of ordered numbers. So they take an average. So this would be rounded to $6.38. And that almost seems like a better measure of central tendency here. And the mode is 625. So I would say that the reason why the mean is skewed upwards, why it's 660, and we said that most employers receive less than 660, is because you had an outlier here. You had one person that received it's like a $2 increase from what most of the workers earned. Okay, so because you had an outlier at $8.25, you skewed your data upward. That's called skewing it. It pulls the center of your the measure of central tendency, that is the mean, it pulls it upward. Whereas the median is more reflective. If I say that most people earn $6.38, then that's a more accurate picture of what most people earn. And certainly the mode reflects what most people earn as well. So the best measure of central tendency given this data set is the median or the mode. So again, going back to our last slide, if you have an outlier, it is not good to use the mean because the mean is either skewed upward or downward by the presence of your outlier. Now, one more thing to go over is the linear transformation of data. So let's say that we have the following data set: 2, 2, 3, 4, and 5. Okay, if you take the mean of this, it would be 3.2. If you take the median, it would be 3, and if you take the mode, it would be 2. Now, let's say that you want to add 10. You want to add 10 to each number. So 2 becomes 12, 2 becomes 12, 13. 3 becomes 13, 4 becomes 14, and 5 becomes 15. So I've taken the old data set and I've just added 10 to each one of them. When I get the mean, I get 13.2, the median is 13, and the mode is 12. Look at the relationship between these three measures of central tendency for these two sets of data. So your mean was 3.2, and your new mean was 13.2. Your median was 3, and your new median was 13. Your mode was 2 before, and now it's 12. So the thing to draw out from this is if you are adding something to every single number in the data set, it only works if you're adding it to every single number, then your measures of central tendency will just be added by that amount as well. Okay? Now let's take the same set of data, and so this is the same set of data we had before, 2, 2, 3, 4, 4. So the mean was 3.2, the median was 3, and the mode was 2. Let's multiply each number in the data set by 3. So we'd get, so our data set this is off a little bit. So let's see if we can calculate it from here. So we multiplied everything by 3, we'd get 6, 6, 9, 12, and 15. So I just multiplied those two. Oh, I didn't reflect. So these should just be 6, right? So everything is correct. Well, this is not correct anyhow. But what I did, I actually used the correct set of information when finding the mean. So I added 6, 6, 9, 12, and 15, and I divided by 5, I got 9.6. Okay, the new median in this set would be 9 because it's the middle of the data. So if you see 9 is in the middle of the data, and the new mode is 6 because 6 appears most often. So let's take away this information for a minute and just look at the relationship between the old measures of central tendency and the new measures. So the old mean was 3.2, the new mean is 9.6. Notice that 3.2 times 3 is 9.6. Okay, the old median was 3, and the new median is 3 times more than that, which is 9. And the old mode was 2, and the new mode is 6. So if you're multiplying each number in the data set, every single number, it has to be every number, by a certain amount, then the measures of central tendency will just be multiplied by that amount again. There's no need to run through the calculations again if you've already done them. Okay, and these are called linear transformations. Linear transformations means to add or subtract, multiply, or divide. Okay, those 4 operations, if you do any of those 4 operations to every single number in the data set, you can just take the 3 measures of central tendency that you may have already calculated and do it to that and get the new measures of central tendency. You cannot, however, for instance, you can't square. So if I had 2, 2, 3, 4, 5, you can't square every number in the data set. So if I took all the numbers and squared them, 4, 4, 9, 16, and 5. You can't square all the numbers and then just square the measures of central tendency and get the same thing. Okay, this is not, and this is reflective of the way that we describe like the function y equals x squared. That's a curve, right? That's a parabola. Whereas numbers that just involve taking an x and multiplying it by something and adding something to it, that ends up being a line. Okay, that's why we call it a linear transformation. Okay, we're just shifting it right or left, or we're expanding the space between the numbers by multiplying them, as opposed to squaring them, which really does something much different to the numbers. Okay, so that's all the lesson for today. So let's review what you learned real quick. You learned that if you multiply or add something to each number in the data set, you can do the same thing for the measure of central tendency. You learned the best measure of central tendency to use given your data. And you did a quick review on the 3 measures of central tendency.